For the most part, if you're going into a business into a business area, you're not going to care about complex solutions, quite honestly, because your models are not going to give them to you that you're working with, because you're usually looking for concrete numbers, because you don't build imaginary widgets. Well, I guess you could be if you're a scam artist, right? You know, you're building imaginary things, and people will buy them because they're going to think they're going to be making money, and they think they're real. It's like many years ago, you had people who were selling land in Florida, and they'd show all of these resort pictures and how gorgeous the land was, and when you went down to see it, it was like swamp. Right, so if a scam artist, maybe, but for the most part, most of you are not going to have to deal with imaginary numbers. But complex zeros, remember, the complex, we're now going to be looking imaginary. Complex also includes real, but we're on imaginary numbers at this point. Zeros, now remember, zeros are solutions, x-intercepts, or could be x-intercepts, and it's always done by taking the function and setting it equal to 0. That's why they're called zeros. So that means I would take x squared plus 25, set it equal to 0. The easiest way to handle this, because this doesn't factor, I can use the square root property on this guy, or you could use the quadratic formula. I'll use the quadratic formula on the next one. So x squared is equal to negative 25, and then we take the square root of both sides. Don't forget the plus or minus. So that x is plus or minus the square root of negative 25, or x is plus or minus what? 5i, yeah. And the issue with this guy, if I were to take x squared minus 2x plus 5 equals 0, I'm going to need to use the quadratic formula on him because he doesn't factor. So a is 1, b is negative 2, c is positive 5, so that x is minus a minus 2 minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, see I wrote a, 2 times 1. Or x is positive 2 plus or minus the square root of all over 2. And this is a positive 4 subtract 20, which is a negative 16. So that x is 2 plus or minus, what's the square root of negative 16? 4i over 2, which is 2 over 2 plus or minus 4 over 2 times I, or 1 plus or minus 2i. Now what the discriminant does is it tells you what kind of solutions you're going to have even before you do it. And sometimes I'll test out if I'm going to have imaginary solutions. It makes no sense to go in and do the problem because the solutions are not real numbers, because I'm looking for real number answers. But what the discriminant is what's under the radicals. So if I were to look at the quadratic formula, it says that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. This determines what kind of solutions I have. because the reason why I knew I had imaginary solutions was because what was under the radical was negative. And the first program, I took a course called Numerical Analysis. The first program that I had to write for that class was a program that did the quadratic formula. And you learned a lot about the quadratic formula at that point. And most calculators, most computers, don't automatically do imaginary numbers. So as a result, if you knew you were going to have imaginary solutions, you'd have to write what's called a subroutine or a subprogram that you would send it to that would enable you to be able to do imaginary numbers, because it didn't normally do imaginary numbers. So you'd have to run a test, and the first test you would run would be what essentially, and let's see if this guy, this guy's too complicated. I've got a couple programs in here that does the quadratic formula. Oops. I need one of my more simple programs. This is too complicated too. These are fairly complicated programs, but first thing you would do is you would test b squared minus 4ac. That would then tell you essentially what kind of solution you were looking for and where it needed to send your information in order to get your solutions out. So that's what the discriminant comes in. And we know for sure, because we just saw it, that if the discriminant b squared minus 4ac is negative, that I'm going to have two imaginary solutions. And then I would go in and I send it to the part of the program that would calculate out imaginary solutions for me. If b squared minus 4ac is positive, well, that would come up with two solutions, because if I were to come back and say, what if this were x squared minus 25 equals 0? Right? This would be x squared equals a positive 25, or x is plus or minus the square root of 25. So what's under the radical is positive. So as a result, I'd have two solutions. So that says, well, if b squared minus 4ac is positive, I'll have two real number solutions. Now the next question would come in, and I'm going to do it on the back of this guy. What if b squared minus 4ac is 0? Well, if b squared minus 4ac is 0, I would have x is equal to minus b plus or minus the square root of 0 over 2a, which is just minus b over 2a. I only have one solution. Because the radical goes away. There's no plus or minus anything anymore. So I would have one real solution. Your book would say one rational solution, but real is fine. So here we go. What kind of solutions do I have? Well, here a is 2, b is negative 4, c is 1. So b squared minus 4ac is minus 4 squared minus 4 times 2 times 1, which is 16 minus 8. That's positive. So what kind of solutions do I have? I have two real, yeah. And here, a is 4, b is 12, c is 9. So b squared minus 4ac is going to be 12 squared minus 4 times 9, which is 144 minus 144, which is 0. So how many solutions do I have? One.